Welcome back. In today's explainer, we are going on a fascinating architectural tour of the stomach. Now, we often think of the stomach as just a simple pouch where our food lands after we swallow, but trust me, it's so much more than that. It is an incredibly dynamic, highly expandable biological factory. It's custom designed to accumulate, vigorously churn, and chemically digest the fuel we take in. We're going to examine its structure exactly like you would a high-tech manufacturing plant, looking closely at its foundation, its structural walls, its internal processing zones, and its wiring. To keep things moving efficiently, here's our roadmap for the explainer today. We'll peel back the layers by covering the neighborhood, anchors and architecture, rooms and doorways, muscles and mucosa, and we'll wrap up with plumbing and wiring. All right, let's jump straight into section 1, the neighborhood. Let's see exactly where this biological factory is located within the human body. If you're visualizing where this sits, the stomach is positioned right up there in the left upper abdominal quadrant. It tucks snugly into the abdominal cavity just below the left dome of your diaphragm. It basically acts as the ultimate bridge connecting your upper and lower gastrointestinal tracts, nestled perfectly between the abdominal esophagus above and the duodenum below. Plus, it's completely wrapped in peritoneum, making it an intraperitoneal organ. And it definitely doesn't sit in isolation. It shares a very crowded, tight-knit neighborhood. Toward the front, it tucks right in behind the left lobe of the liver and against the anterior abdominal wall. Towards the back, it rests just in front of the pancreas, the spleen, and the left kidney. Down below, it connects with the transverse colon and the greater omentum. It is a highly connected premium piece of anatomical real estate. Moving right along to section 2, anchors and architecture. Because honestly, a highly active, constantly expanding organ like this absolutely needs to be securely bolted down. To keep things stable, the stomach relies on critical peritoneal ligaments formed by its outermost layer fusing with the peritoneum. Think of these 4 key ligaments as heavy-duty scaffolding. We've got the epigastric ligament connecting it to the liver, the gastrophrenic ligament anchoring it up to the diaphragm, the gastrosplenic ligament reaching over to the spleen, and finally, the gastrocolic ligament hanging down to the transverse colon. Together, this scaffolding fixes the stomach in place, crucially preventing it from twisting around dangerously when it expands. Okay, section 3, rooms and doorways. Now that we know where it lives and how it's anchored against the elements, let's step inside and explore the layout of the factory floor itself. Anatomically speaking, the interior is divided into 4 main rooms, and each has a very distinct role. First up is the cardia, which is the initial entry zone right around the cardiac orifice. Next is the fundus, that dome-shaped part up top. Then we have the body, or corpus, which is the massive central processing area. And finally, the pyloric part, which acts like a funnel-like exit into the duodenum. Now, here's a fun aside. While anatomically there are 4 distinct rooms, histologically, the body and fundus actually share the exact same microscopic characteristics. Now, what's really fascinating here is the fundus. It's that rounded dome at the very top. Because it sits higher up than the cardiac opening, when you're standing upright, this area naturally fills with gas. This creates a distinct stomach bubble that medical professionals can clearly spot on standard x-rays. Literally a bubble of trapped air just sitting there. So the crucial point we have to keep in mind is understanding exactly what this entire 4-room facility is designed to produce. And that end product is chyme. The stomach's primary mechanical job is to take solid chunks of food, mix them vigorously with highly acidic gastric juice, and transform the whole mess into a thick, semi-fluid paste that is ready to be processed by the lower intestines. To effectively process and direct all that chyme downward, the stomach is built as a highly recognizable J-shaped funnel. It's bounded by 2 primary borders. On the left side, we have the long, convex, greater curvature, swooping all the way down from the top. On the right side is the much shorter, concave, lesser curvature. These 2 curvatures essentially shape the factory's main mixing vat. But hey, a factory needs doors, right? And the doorways to this facility are guarded by strict bouncers called sphincters. Up at the top, we have the lower esophageal sphincter. It's physiologic, mostly preventing acidic contents from splashing back up into your esophagus. At the bottom, though, we have something much more robust, the pyloric sphincter. This one is a thick, anatomical ring of muscle that meticulously controls the exit, releasing our newly formed chyme into the duodenum in controlled, tiny waves.
All right, Section 4, Muscles and Mucosa. Let's transition from the layout of the rooms to the actual structural materials that give the stomach its incredible mechanical churning power.
If you look at the innermost lining, the gastric mucosa, you'll immediately notice it is definitely not smooth. It features deep, wrinkled folds called gastric rugae. These act exactly like an expandable accordion. When your stomach is empty, these rugae are highly visible, and the organ holds a mere 50 milliliters. But as you eat, they physically stretch out, allowing the stomach to hold up to 4 liters of food. There's even a specific track along the lesser curvature where these folds run lengthwise, creating a gastric canal that lets liquids fast-track straight to the exit.
But right beneath that dynamic lining lies the real powerhouse, a totally unique 3-layered muscular wall. See, most of your digestive tract gets by just fine with 2 muscle layers. But the stomach? It packs an extra inner oblique layer explicitly designed for heavy-duty multidirectional churning. Layered on top of that is the middle circular layer, and finally, the outer longitudinal layer. This triple threat configuration is exactly what allows the stomach to completely pummel your food into chyme. Which brings us to Section 5, Plumbing and Wiring. Obviously, no biological factory runs without power and plumbing, so let's examine those vital supply lines.
Here we see the intricate plumbing system. You've got a rich arterial supply branching off the celiac trunk, with gastric arteries running right along the curvatures to act as dual supply lines. And this is mirrored precisely by a venous drainage network. Those veins collect the oxygen-depleted but very nutrient-rich blood and funnel it directly into the hepatic portal vein system to be sent straight to the liver.
Now, what is truly mind-blowing from an architectural standpoint is the redundancy built into the system. As these vessels penetrate the stomach wall, they form abundant internal collaterals known as intramural vessels. They weave together into such a dense, interconnected safety net that the stomach tissue can easily survive even if one of the major external supply arteries gets pinched off or blocked. The factory just brilliantly reroutes the power.
Wrapping tightly around all of this plumbing is the autonomic nervous system's wiring. This incredibly complex nerve netting is constantly regulating the factory's operational tempo. It's dictating the volume of gastric juice being secreted and the speed and intensity of that muscular churning, all completely outside of our conscious control. The body manages this through a brilliant dual control system. It's basically a constant tug of war. The parasympathetic system, driven by the massive vagus nerves, hits the gas pedal for rest and digest operations. It ramps up acid secretion and gets things moving. On the flip side, the sympathetic system acts as the brakes. During a stressful fight-or-flight moment, it halts digestion entirely, clamping down the exit to divert the body's precious energy elsewhere. And that brings us to the end of our architectural tour. But it leaves us with a pretty fascinating question to ponder. We've seen the elegant design, the expansive rugae, the heavy-duty muscle, and the delicate tug-of-war of autonomic wiring. But when you consider the raw, destructive power of stomach acid, what actually happens when this precise control system gets even slightly out of sync? The line between healthy digestion and painful chaos is a lot thinner than you might think. Thanks for joining me on this explainer, and keep questioning how the incredible machines inside us actually work.